the principles. All right. So first principle of derivative is what the formula that was developed earlier on. If you don't know how to derive the first principle, please go back and watch Power Rule 1, the lecture video on Power Rule 1. I've demonstrated all of that in there. So from the first principle of derivative, differentiating some types of functions. If the function that you are differentiating is in the power form, meaning if the function is of the form y is equal to x raised to the power and a, where a is a number, then y is equal to x raised to the power a is in the power form. So when the function is in the power form and you differentiate using the first principle of derivative, you will get the same answer if you apply the power rule of derivative. And the power rule of derivative, like I mentioned, if the function is in the form y is equal to x raised to the power a, if this is reversed, if your function is in the form a, where a is a number raised to the power x, this is not in the power form. So you cannot use the power rule of differentiation to differentiate that. All right, so given y is equal to x raised to the power a, we can find the derivative of this function using the first principle. We can also use the power rule because the function is in the power form. And so to differentiate this function means we are looking for a very small change in y with respect to a very small change in x. So we have dy dx. We have seen dy dx so far or earlier on, and they were in the form delta y over delta x. When you want to find the slope of a straight line, you use the formula change in y over change in x. We use this particular formula when we know two big points on the line. So I have a straight line. I want to find the slope. I'll pick 2 points on the straight line, find the change in the y with respect to the change in the x. However, when you don't have a straight line, or when you have a line that has only 1 point on it, then finding the slope of such a line becomes difficult because to find slope, you need 2 points. And so instead of delta y over delta x, we are looking for a small change in y over a small change in the x. So the dy dx is nothing out of context from what we are used to so far in algebra, in geometry, where you're looking for the slope of a line and it is always equal to delta y over delta x. So dy dx is equal to, using the power rule of differentiation, we multiply the number on top of the x by the coefficient of the x. Since the coefficient of the x in this expression here is 1, we'll have a times 1, that is a, then x. After getting ax, we subtract 1 from the power. So instead of a, we are going to have a minus 1. And this is what is known as the power rule of differentiation. If the function is in the power form, multiply the number on top of the x, or on top of your variable, your independent variable, by the x. So you have ax. Subtract 1 from the power, and that gives you a minus 1. So that is that for the power rule of differentiation. I don't think that is quite difficult. Now let's look at when we want to differentiate using the first principle of derivative. Given any function y is equal to f of x, to find the slope of a line that is tangent to this curve, meaning this line that we are going to find the slope of has only 1 point. And so instead of using the delta y over delta x, we are going to use small change in y over small change in the x. From the first principle of derivative, small change in y over small change in x is given by the limit as h approaches 0 of f of x plus h minus f of x all over h. I've shown a way how you can generate this formula from the videos that I sent. So if you still not watch it, what we are going to do today, you'll be lost. So this is a formula for finding the slope or finding the rate of change of a function given by y is equal to f of x. We write this as change in y over change in x, a very small change in y over a very small change in x, limit as h approaches 0 of f of x plus h minus f of x all over h. This is just a formula, all right? So given the function, you put this, the function that has been given into this formula, and then you simplify. Using this approach is what is known as the first principle of derivative. So let's look at attempting the first question. The first question is y is equal to x raised to the power 3. We want to find the slope or the rate of change of this function. This means that we are going to find a small change in y over a small change in the x. And this is equal to, I'll write down the first part of the formula, and that is the limit as h approaches 0. Then the next step is to put the function in this form. From the original function, y is equal to f of x. To put this into the formula, you notice that we don't write it as f of x, but we write it as x plus h, meaning we go into the function, remove whatever is inside, and then put x plus h there. All right, given y is equal to f of x, the second part of the formula, which is f of x plus h, if you compare it with the original function, the only thing that has changed is it looks as if we have gone into the bracket, all right? Whatever the f is containing, we have removed it and replaced it with x plus h. So to write the second part of the function of the formula, using this function here, it means that we are going to go into the function, remove the x, and put x plus h there. But since the x is raised to the power 3, for the second part of our function, we'll have the x plus h, all right. But the function is not just x, it is x raised to the power 3. So we have x plus h all cubed. Minus, we go to the third part of the equation, the formula. The third part of the formula is f of x, which is the original function that you've been given. So for here, I have x plus h all cubed minus the function itself, which is x cubed, divided by h. Now, I must admit, this is one of the daunting tasks when you want to use the first principle of derivative. The only thing that changes is this part here. Go to the function, wherever you see x, remove it, and then put x plus h there. Everything else, you need to maintain it. What we are left with is to simplify the expression that we have. So our next step is this is equal to the limit as h approaches 0, x plus h all cubed. We need to expand this. Luckily, we have algebra. So this here is x plus h times x plus h times x plus h. We're expanding this part here. This is x plus h all cubed. So it's the same as x plus h times x plus h times x plus h. Multiply the first by the second, the answer you multiplied by the third. However, we can also use a shortcut, which is the Pascal's triangle. And using the Pascal's triangle, x plus h all cubed will be equal to, you cube the first term, and that is x cubed, plus multiply the exponent by both x and the h, so 3x and h. Make sure that the powers you put on top of the x and the h sum up to 3, because the power for the entire expression is 3. So if we are introducing x and h, it means that the powers I put on top of the x and the h must sum up to 3. So I'll put 2 here and then I'll put 1 there. Plus 3 times the same x and h, powers must sum up to 3. Since I put 2 on the x, this time I'm going to put 1 on the x and I'll put 2 on the h. Plus the last term is to cube the last term, so h cubed. All right, so my x plus h, let me write it here well, x plus h all cubed is the same as we cube the first term, x cubed, plus multiply the power, which is 3, by 3x and the h, so 3xh. Make sure that the powers sum up to 3, so I have 2 here and I have 1 there. Plus 3x and h, make sure that the powers sum up to 3. Since in the first term here, I put 2 on the x. Here I'm going to put 1 on the x and put 2 on the h. Plus our last term, which is h cubed. Or you could do the x plus h times x plus h times x plus h, which is tedious. We are lazy. So we are going to use algebra, employ algebra, because we are doing algebra at the moment. So the expanded form of this term here is x cubed plus 3x squared h plus 3xh squared plus h cubed. That is the expanded form of x plus h all cubed. Minus, maintain my x cubed, all divided by h. Next step, let's simplify a little bit. Limit as h approaches 0. We can remove the bracket. All right, so if I remove this bracket and remove that bracket, there is something we can do here. And that what we can do here is I have positive x cubed and I have negative x cubed. They can get rid of each other. So what we are left with is 3x squared h plus 3xh squared plus h cubed, all divided by h. Next is to look through the expression and see if we can simplify further. And the answer is yes, we can. And what we can do is we notice that there's h here, there's h here, there's h here, there's h here. So our next step is to factorize the h out. And so my dy dx is equal to the limit as h approaches 0. I'm factorizing h out of the numerator. If I factorize h out of the 3x squared h, I'll be left with 3x squared. Then plus, if I factorize h out of the 3xh squared, I'll be left with 3x, one of the h's remaining. Plus, there are 3 of the h's here. If I factorize 1 out, I'll be left with only 2 of the h's, divided by my h here. Now we can cancel this h and cancel that h. Next, this is limit as h approaches 0 of 3x squared plus 3xh plus h squared. Limit means wherever we see h, we are going to approximate that to be equal to 0. So this is equal to 3x squared, there's no h, plus I have an h here, 3x times 0 plus 0 squared. And this is equal to 3x squared plus 0 plus 0. And the answer is 3x squared. So my dy dx is equal to 3x squared, where y was equal to x cubed. This is the answer we've gotten using the first principle of derivative. The question states that after using the first principle of derivative, verify your answer using the power rule. So to verify using the power rule means that we need to check if the function is in the power form first. If the function is not in the power form, we cannot use the power rule, and hence the name power rule. So power function means I have x raised to the power a number. I have x raised to the power 3. 3 is a number. Therefore, this function here is in the power form. And so we can use the power rule. And the power rule of derivatives. So using the power rule of derivative states that change in y over change in x is equal to multiply the power. And the power in this case here is 3. So multiply the power by the coefficient of the variable x. The coefficient of this variable here, the number here is 1. So I'll have 3 times 1, and that is 3x. Next is to subtract 1 from the power. 3 minus 1. And so the answer is 3x raised to the power 2, which is the same answer we got when we use the first principle of derivative, which is very long and daunting. But it is daunting because you need to use a whole lot of algebra to be able to get your final answer. And using the power rule, just multiply the power by the x, that will be 3x, subtract 1 from the power, so our final answer is 3x squared. The second question was y is equal to 2x squared. So once again, to use the first principle of derivative, if y is equal to f of x, then change in y over change in x is given by the limit as h approaches 0 of f of x plus h minus f of x all over h. That is the formula for finding the derivative of a function. And this formula is known as the first principle of derivative. So we are going to compare the function that we want to differentiate with the function that gave birth to the first principle of derivative. And the function we are going to differentiate is 2x squared. So let's attempt to put this into the first principle formula. This is equal to limit as h approaches 0. Our first task will be to put this in this form. And to get this form, it means that we need to go to the function, remove the x, and then wherever the x is, we put x plus h there. So from the first part, we are going to have, there's a 2, there's no x, but the x is here. So I'm going to open bracket and put the x plus h there. But the x is not alone. There's a power on top of the x. So I'll have 2 there. Minus, the second part of the formula is f of x, which is the original function itself. So to put that in here, using this formula, I'll have minus, the original function is 2x squared, all over h. Then the next is to simplify. So this is equal to the limit as h approaches 0. I have 2. To simplify this bracket here, I have x plus h all squared. So x plus h all squared is the same as x plus h times x plus h. Then we'll multiply the x by the x by the h by the x, h by the h. However, we can use algebra. And in algebra, if I have x plus h all squared, this is the same as square the first, x squared, plus multiply the power by the first and the second, so 2xh. Make sure that the powers sum up to the power on top of the expression. Power here is 1, power there is 1, 1 plus 1 is 2, so we are on track. Plus the last term squared, h squared. So if I put that in here, I have x squared plus 2xh plus h squared minus 2x squared. My original 2x squared that was there. All over h. Step-by-step simplification. Limit as h approaches 0. We can expand the expression by multiplying 2 by every single term in the bracket. So I have 2 times the x squared, that will give me 2x squared. plus 2 times the 2xh, that will be 4xh, plus 2 times the h squared, that will be 2h squared. Then I'll have my minus 2x squared, which is this expression here, all over h. Next step is to look through if there is anything that we can simplify. We have the 2x squared here, and then we have negative 2x squared. They can get rid of each other. So the expression simplifies to limit as h 0 of 4xh plus 2h squared divided by h. Is there anything else we can simplify? Yes. I have h in the first term, h in the second term, h in the denominator, so we can factorize h out. So we have limit as h approaches 0, h out of the first term, that will be 4x, plus h out of the second term, and that will be 2h, all divided by h. Now we can cancel this h and that h, that will give us 1 and 1. So this is limit as h approaches 0 of 4x plus 2h. Limit means wherever to evaluate the limit of a function means that wherever we see h, we are going to approximate that to be equal to 0. So this will give us 4x. I don't see any h, so I will leave it alone, treat it as if it's a constant, plus 2 times 0. And that will be 4x plus 0, which is equal to 4x. So my dy dx is equal to 4x, where y was equal to 2x squared. Using the first principle of derivative, this is the solution we have. The question says, verify your answer using the power rule. To verify our answer using the power rule, first step is to make sure that your function is in the power form. And in the power form means that you have an x raised to the power a number. And yes, it is in the power form because I have an x raised to the power a number. And so to use the power rule of differentiation, because the function is in the power form, we have dy dx is equal to multiply the power by the coefficient of the x. The coefficient of the x is 2. So multiply the power, which is 2, by the 2, and the answer will be 4x. Next step is to subtract 1 from the power. So I have 2 minus 1. And that will give me 4x raised to the power 2 minus 1 is 1. 4x raised to the power 1 is the same as 4x, which is the same as when we use the first principle of derivative. And if you compare the two, the power rule of differentiation is much more simpler. Then the last question was y is equal to square root of x. To differentiate this function using the first principle and after that verifying, let's write down the formula. Given y is equal to f of x, dy dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. All right, so given that formula, our dy dx is the limit as h approaches 0. Remember to write down this part. We go to the function. Wherever we see x, remove the x and put what the x plus h. So for the first part, we are going to have square root of x plus h. Minus what follows after that? What follows after that is the original function itself. So minus square root of x all over h. This is equal to the limit as h approaches 0. Now we have square root of x plus h minus square root of x all over h. we need to simplify this. We cannot apply the limit yet, because if you apply the limit now, you are going to have square root of x plus 0 minus square root of x all over 0. This will be square root of x minus square root of x divided by 0. Root of x minus root of x, that will be 0 over 0. This is indeterminate, right? So we cannot apply the limit yet, because if we apply the limit, we are going to get indeterminate. Indeterminate, you look at the function that you have, employ the appropriate technique. Since the functions that we have are in the sets form, to simplify sets, we cannot use factorization like we have been doing so far. No. To simplify sets, we use conjugation. And the first step towards conjugation is to find a set. Find its conjugate, multiply both the top and the bottom by the conjugate of the set. Since the set is square root of x plus h minus square root of x, its conjugate will be, so the conjugate of this set will be square root of x plus h plus square root of x. This is the expression we use to multiply both top and then the bottom of the function. All right, so our next step towards simplification is we have root of x plus h minus root of x divided by h. We multiply both top and down by the conjugate of the set. So times root of x plus h plus root of x divided by root of x plus h plus the square root of x. This is the limit as h approaches 0. We put the tops together, put the bottoms together. So the tops will have root of x plus h minus square root of x, root of x plus h plus square root of x. Divided by, we put the bottoms together, h times square root of x plus h plus square root of x. This is equal to the limit as h approaches 0. We multiply this term here, or this expression here, by this expression. Meaning, pick this and multiply by that. The same expression multiplied by this. Come back and pick the minus root x multiplied by this. The same minus root x multiplied by that. But we are not going to do that. And this is because we know that the terms within the two brackets are the same, the signs alternate. So the two brackets are the form a minus b times a plus b. In algebra, we know that if I have a minus b times a plus b, this is known as the difference of two squares. This is given by a squared minus b squared. Simply pick the first term and square it, minus pick the second term and square it. So using that technique, the next step is we are going to pick the first term, which is the square root of x plus h. We square it. Minus, we pick the second term, that is square root of x, and then we square it. And we are done. We don't need to do the one by one multiplication. All divided by our h times root of x plus h plus root of x. Limit as h approaches 0. Square and the square root get rid of each other. Square and the square root get rid of each other. So from the first term, we'll have x plus h. Minus the second term, we are just left with x divided by h into bracket, root of x plus h plus root of x. This is equal to the limit as h approaches 0. If we open the brackets here, we have x plus h minus x. You notice that I have positive x and I have negative x. They will get rid of each other. So what I'm left with at the top is just the h. However, I have h at the top, I have h at the bottom, and so they cancel each other. And what I have left here is 1, and what I have left here is also 1. So the expression simplifies to 1 divided by square root of x plus h minus plus square root of x. Now we can apply the limit. Apply the limit on the top. Applying the limit on the top, I don't see an h, so I maintain my 1. Limit of a constant is the constant itself, divided by square root of x plus 0 plus square root of x. This is equal to 1 over square root of x plus square root of x. And that is root of x plus root of x, that is 2 root x. So the answer, which is 1 over 2 root x, given that y is equal to square root of x. This is the answer we get when we use the first principle of derivative. The question says verify your answer using the power rule. And to verify using the power rule, we first of all need to make sure that our function is in the power form. Looking at the function, technically it's not in the power form because I don't have x raised to the power a number. However, we can write it as x raised to the power half because square root of any expression or square root of any number is that number raised to the power a half. So root of x, we can write it as x raised to the power half. Now the function is in the power form. And so we are allowed to use the power rule of derivative. Using the power rule of derivative, we'll have dy dx. This is equal to multiply the power by the coefficient of the x. The coefficient of the x is 1. So half times 1 is half. X. Subtract 1 from the power. The power is half minus 1. So this is equal to 1 over 2 x raised to the power half minus 1, that will be minus half. In indices, if I have a number raised to the power negative and I want to get rid of the negative exponent, you find the reciprocal of the number. And so if I want to get rid of the negative half, all I have to do, since it's at the top, all I have to do is to bring it to the denominator side. And if it were to be at the denominator side, all I have to do is to take it to the top. So this is the same as 1 divided by 2x raised to the power half. Once it comes down, it becomes positive. We've said earlier on that if I have any number x raised to the power half is the same as square root of x. So the answer is 1 divided by 2 root x, which is the same that we had when we used the first principle of derivative. So these are the solutions to the questions, and these were the expectation. Find the derivative using the first principle, and then after that you verify your answer using the power rule of derivative. How many were able to do it this way without using AI? I have not checked yet because I keep getting because excuses. I could not submit because a whole lot. So how many were able to do it in this sequence without using AI?
I did.
You did? Okay. Yeah. Okay. So I see a hand.
Madam, no.
Yeah, I did it with AI.
Yeah, this because if you are confused because you did not watch the video.
Madam, good afternoon.
Good afternoon.
Please, thank you. Please, my issue is some of us we didn't verify the the answers using the power rule.
Okay. But you did using the first principle of
Yes,
derivative.
yes.
Okay.
Thank
Okay.
you.
So in such a case, you will get 70%. You're not going to get 100%.
Oh, madam.
You will get 70%.
Yes, madam. And your method seems a lot shorter. When you go to the factorization side, especially with the sets, the subjugating method,
The conjugation. Okay.
yes, the conjugating method. Mine was very long because I factorized them out again and then canceled them.
Hey.
But I still got the same answer.
Yeah, you get the
But
same answer. That's all right. Step by step, you get
yes, so that I will understand when I'm revising how I
yes.
got that difference of 2 squares.
Okay.
Yeah.
Okay. With more experience, you get to a point where you'll be jumping steps, and then you realize that it's not everything that you need to include.
Amen.
Hey, it's not my aim.
Amen.
It's
Madam,
not.
please, some of us, you see, we didn't join the Telegram page early, so we didn't get the video to watch. If you can resend
Hey,
it again.
so if they had told you that the woman has shared lotto numbers,
Which madam will not share the two numbers?
if they had told you that this Telegram group, when we created it, the woman shared lotto numbers, would you not have checked
That
them?
one is that one. That
Madam,
one is money matter. Man, that one is money matter. It's money matter.
This country
madam,
is
that
not
one is there. You
matter.
see,
This
lotto
one
number is
is
different.
this
Madam,
one
that
is
one is there.
money matter. This is what you're going to use to make the big money.
And madam, that's why we want you to resend the money, the process to get the money.
I came.
Eh? Get the certificate, and then that's what you're going to use to make the big money.
The lotto is instant money.
The lotto is instant too. If the number doesn't come, that is it. We are
I
gone.
have Nana Kofi. You can come in.
But so please resend the video so we can watch again.
Hey, my people, I hear. I will resend the videos. So
Madam,
if you did not watch,
I
if you did not watch the videos,
Thank you, madam.
how did you do the work?
Bam. Thank you, madam.
Ayo, madam.
Madam, please use AI.
Madam, AI was alive.
Hi.
And AI was working. AI was working.
Hi.
Hello, madam. Please share the video with us. Okay, madam.
I hear.
Madam, you didn't use AI.
They did. I know you did. Even with the write-up, when I started reading it, I realized, this one is ChatGPT. This one is Grok. This one, I saw the
Students are truthful.
yes, I saw the right. I know how Grok writes, and I know how ChatGPT also writes. I know how the other AIs write. I saw all of them. Let's try as much as possible for academic work. If you're submitting something, make sure that it's your own work. But for verification purposes, you can use AI. But to use AI to submit work, it sounds like it's a not to get on the wrong side. It is very disrespectful. If you don't see it that way, it is very disrespectful that you've been given an assignment. You not make any attempt at all to do it. No attempt at all. You just put the work to AI and then it just writes up for you. No time to even read through what you've written. And then you submit it as, no, it's very disrespectful. All I was expecting is something simple. Well, my understanding before the class started was very small. But as time is going on, the rate at which I am understanding the work is changing. That is differentiation. Something as simple. When I'm walking, my distance has changed. Time has changed. That is also calculus. I added so and so together and made a bulk entity. That is calculus. That is integration. Or I'm into construction. I put the roofing, I put the windows, I put the doors and everything. I've gotten one bulk structure, one building, which is that is integration. So I wasn't expecting something so big, the stuff you wrote there. I'm sure if I ask you to come and defend, we'll find ourselves in trouble. So please, let's try as much as possible, especially first year. If it's final year and it's a project that you are doing and you want to use AI, that is fine. But for first years where you are building your foundation and you're using AI, it's not going to help. And the way technology is advancing is in such a way that if all you can do, all right, if AI can replace it, imagine 5, 10 years to come. Do you think I will hire you? No, because why would I hire you to do work that AI can do for me? I don't need to employ you. No. So learn a skill, learn something. Yeah, AI can do this for me, but I can also do it this way. But if it's all AI, if you see how technology has advanced, a lot of IT corporations, their junior programmers, their junior IT specialists, they are all being sacked. They are all being let go. And that is because AI can do essentially everything they can do. These days, secretariats and managerial positions, they are not needed anymore because AI can do that. So if for starters, we just relying on AI and not building skills and not learning things on our own, then it's going to be very sad. So let's try as much as possible to learn something small. I know it's difficult. With the level at which AI can do a lot of stuff for you, it is difficult not to rely on it, but you are not training your brain as well. So let's try and put a stop to it. All right, so with that being said, yeah, somebody's hand is up. Otabel, your hand is up.
Yes, madam. Madam, please, good afternoon.
Good afternoon.
Madam, please, I've watched the video you uploaded on Telegram.
Okay.
And as I watched it, I still didn't get the understanding. By you doing the explanation here, I think I'm getting everything.
But it's the
So I'm
same thing
pleading
that I'm
with you.
saying. It's the same thing.
It
It's the
seems
same.
this.
It's the same
I
thing.
didn't get the understanding when I watched. So I'm pleading with you if you can actually go over here for me.
You want me to go over the video?
Yes, please. Here. I beg you, please.
So
It's,
when will Madam have time to give us the apple?
Oh, madam,
Please
please, you can go over the video yourself.
allow.
it's a video. No, that's where my surprise is. It's a video. It's like you have a DVD, right? You have a DVD of maybe a movie or a set of movies. And then you meet the actors, and then you want them to act the same thing in front of you, whilst you have the DVD.
Now, wow.
I want to meet the producer now.
you, yeah, but then it's the same movie you want me to show to you. It's the same movie you want me to
Madam,
act. Yes.
madam, please, he will join the class. Please proceed.
Yeah. So please, it's a video. If you are stuck somewhere, then we can address it. But to go over, then we will not finish. We'll not get anywhere. All right, so derivative y, to find the derivative of functions of the form y is equal to, yes, please.
Madam, please, talking about the video, the
Okay.
last rule, that is the quotient rule. I
Mm-hmm.
find it a bit difficult, but with the
Okay.
other ones, yes.
Okay. So yeah, that is okay. We can I think a lot of challenges arise in the quotient rule. We can go
Yes.
over that.
Okay.
Please don't say because it's a woman that asks, that's why I want to
I
go over.
wanted to say that.
So briefly, there are several properties of derivative. We have seen the power rule of derivative. That is when the function is in the form y is equal to x raised to the power n. Then we can use the power rule, and that is changing y over changing x is equal to multiply the n by the x. So we have nx, subtract 1 from the power n minus 1. Now, sometimes the function could be not just one function, but multiple functions with variety of operators between them. So let's look at the multiple functions and then how some of the functions may be arranged. Given functions, if the operator between them is the summation operator, given two functions f of x plus g of x, and the operator between them is a summation operator, then we use the property known as the sum property. And the sum property states that differentiate the first function plus differentiate the second function. And that we can prove this. We just don't need to do it now. Right? It is true that if you want to differentiate y is equal to f of x plus g of x, just differentiate the first function, maintain the operator, and differentiate the second function. This is what is known as the summation property. So for this function, we'll have dy dx is equal to differentiate the f, that will be the f dx, plus differentiate the g, that will be the g dx. So example, if we have y is equal to x raised to the power 9 plus x raised to the power minus 9, to differentiate this function, we cannot sum them because the powers are not the same. So we cannot sum it to get one function. If the powers were the same, then we can sum them and get 2x raised to the power 9 or 2x raised to the power minus 9. But in this case, the powers are not the same, so we cannot sum them. Therefore, we need to treat them as separate functions. And so we differentiate it separately, and that is to use the sum property. So dy dx is equal to, we go to the first function, x raised to the power 9. It's in the power form, so we can use the power rule. And the power rule of differentiation, we multiply the power by the power by the x, that will give us 9x. Subtract 1 from the power, 9 minus 1. Then we go to the second function, plus, it's also in the power form. We have x raised to the power a number, so we can use the power rule of differentiation. And the power rule of differentiation, we multiply the exponent by the x, so that is minus 9x, subtract 1 from the power, minus 9 minus 1. What you are left with is to just simplify. So this part here is the calculus part. Whatever you need to do next is algebra. And that is, this is equal to 9x, 9 minus 1, that will give us 8. Positive and then negative here, we'll have minus 9x, minus 9 minus 1, that will give us minus 10. So the answer is 9x raised to the power 8 minus 9x raised to the power minus 10. You can decide to factorize the 9 out, or you can leave your answer in this form. Then when the operator between them, if the operator between them is the difference operator, for instance, if we have y is equal to f of x minus g of x, we use what is known as the difference property. And with the difference property, we find the derivative of the first minus the derivative of the second. So here my dy dx will be equal to the f dx minus the g dx. Differentiate the first minus differentiate the second. So example, if we have y is equal to x cubed minus 3x squared, to differentiate this function, we try and see if we can simplify it, because in a simplified form, it's easier to differentiate. An operator between them here is a subtraction operator, meaning we are going to subtract this from the first term, but we cannot subtract because the powers are not the same. Although the variables are the same, the powers are not the same. Therefore, we cannot subtract it or simplify into one function. So we treat it as separate function and differentiate it using the difference property because the operator is the difference operator. To differentiate the first term, we have x cubed. It's in a power form. So using the power rule of differentiation, multiply the 3 by the x, that will give us 3x. Subtract 1 from the power, 3 minus 1. Then minus, we differentiate the 3x squared. It's also in the power form. Using the power rule, multiply the 2 by the coefficient of the x. 2 times 3, that will be 6x. Subtract 1 from the power. What we need to do next is to simplify. So this is equal to 3x, 3 minus 1, that will be 2, minus 6x, 2 minus 1 is 1. But x raised to the power 1 is the same as x. So our answer is 3x squared minus 6x. You can decide to simplify if your algebra is strong, or you can leave your answer in this form. Next is if the operator between them is the product operator. Then to differentiate them, no, I know what you're thinking. Differentiate this times differentiate that, no. We use the property known as the product rule, or the product property, or the product rule. And that is keep one of the functions constant, differentiate the other function, plus the reverse. So if you are keeping f of x constant, then it means that you need to differentiate g of x. Plus, this time around, you differentiate f of x and keep constant g of x. Any of them is allowed. This is what I'm talking about. This is dy dx is equal to, if we decide to keep the first function constant, it means we are not going to differentiate it. We don't touch it. Leave it as it is. Times, we differentiate the second function. So here we'll have d over dx of our g of x, plus the opposite of what we have just done. And the opposite is we'll differentiate f and then keep g constant. So we'll keep g constant times differentiate f. You can decide to switch them around. That is okay. So example of this, if we have y is equal to hey, my pen is misbehaving. Square root of x times x to the power 4 plus 1. Well, here you can expand it and then use the summation property, or you can leave it as it is and treat it as if this is one function times another function, and then use the product rule, or distribute this over what is inside the bracket here. Root of x times this plus root of x times that. If your algebra is not strong, leave it as it is. Treat it as a product of two functions and then use the product rule. Using the product rule, we have dy dx is equal to keep any of them constant. So if we are keeping the root of x constant, then it means that we are not going to touch it. So I'll write down my root of x times, we go inside the second bracket or the second function and then differentiate it. All right, so we'll differentiate what is in here. Let me write it down. X to the power 4 plus 1. I'm going to differentiate it. So I'm putting a prime on top. Plus, since in the first part, we kept the first function constant. In the second part, we are going to differentiate that function and keep the second function constant. So I'll have x to the power 4 plus 1. I'm going to keep this constant. But what I'm going to differentiate is the function that I kept constant in the first part. So root of x, I'm going to differentiate that. So I'm going to put a prime on top. Next is to do the differentiation. So since we kept root of x constant times, if we are to differentiate this, what is inside this bracket, we need to differentiate x to the power 4 plus we differentiate 1. X to the power 4 is in the power form, and so we can use the power rule. And in the power rule, all we have to do is multiply the power by the x, so I have 4x, subtract 1 from the power. The power is 4. If I subtract 1 from it, I'll be left with 3. So the derivative of x to the power 4 is 4x cubed. Plus, we differentiate 1. The derivative of a constant is always equal to 0. Then we go to the second part. All right, so we're going to differentiate or simplify what we have there. We kept x to the power 4 plus 1 constant. And now we have to differentiate root of x. Root of x in its state is not in the power form, so we cannot use the power rule. However, we can switch it into the power form. And in the power form, it is simply x raised to the power a half. Now, root of x is in the power form. Using the power rule technique, we need to multiply the power by the x. So I have half x, subtract 1 from the power. Half minus 1. What we are to do next is to simplify. So this is square root of x into bracket 4x cubed plus I have x to the power 4 plus 1, and then what inside this is half x raised to the power minus half. You can simplify it, or you can leave your answer in this form. Any of them is acceptable. So if you decide to leave your answer in this form, you are not wrong. If your algebra is strong, you can also decide to simplify a little bit further. Then the last property is when the operator between them is the quotient. So given y is equal to f of x divided by g of x, since the operator between the two functions is the quotient, or since the function is in the quotient form, we use what is known as the quotient property or the quotient rule of differentiation. With the quotient rule, given y is equal to f of x divided by g of x, dy dx is, first we keep the denominator constant. So I'll have g of x, differentiate the numerator. All right, so this is in a specific order. Keep the denominator constant and then differentiate the numerator. So I'll have f prime of x. Prime means I'm differentiating once. Prime will mean I'm differentiating twice. Prime means I'm differentiating 3 times. All right, so for the quotient property, keep the denominator constant and then differentiate the numerator. This is in a specific order. Minus the reverse. Keep the numerator constant. Keep the numerator constant and then differentiate the denominator. And this is because we can change this expression here. Y is equal to f of x divided by g of x. We can change this into the product rule, given by f of x times g inverse of x. Using the product rule, keep one of them constant, differentiate the other, minus the reverse. And then if you simplify, you will get the minus there, because if your g comes up, it will have the exponent -1 all over the denominator squared. So g squared. And that is the product property of derivative, right? So let's look at multiple examples. With multiple examples, this property will always stick in your brain. So if I have y is equal to square root of x divided by x squared plus 1, we cannot divide this to get a single function. And so we have to treat it as if it is 2 different functions. The operator between them is a quotient. Therefore, we need to use the quotient property of derivative. We could also decide to write this as square root of x times x squared plus 1 all raised to the power -1 and use the product rule. You arrive at the same answer. However, if we are sticking to the way the function has been given and treating it as if it's a quotient of 2 functions, Then we have to use the the quotient property or the quotient rule. And in the quotient rule, we'll have dy dx equal to, keep the denominator constant. So I have x squared plus 1, and then differentiate the numerator. So my next step is to differentiate root of x. So I'm going to write down the root of x with a prime at the top, meaning I'm going to differentiate this, minus the opposite. And the opposite is, we'll keep the root x constant times we differentiate the other function, x squared plus 1. We are going to differentiate this, so I'll put a prime at the top. All of this divided by the square of the denominator. So here we have x squared plus 1 all squared. All right, so let's do this derivative and then a simplification if possible. So from the first part, we have x squared plus 1. If we differentiate root of x on its own is not in the power form, but it's in the form x raised to the power a half. Using the power rule, multiply the half by the x, subtract 1 from the half, minus half. So here our answer is 1 over 2x raised to the power minus half. Minus, maintain your root x because there is no prime at the top, times, the prime here means that we need to differentiate what is inside the bracket. So we differentiate the x squared. The x squared is in the power form. So you multiply the power by the x, so we have 2x, subtract 1 from the power. The power is 2. 2 minus 1 is 1. Any number raised to the power 1 is the same number, so we remove the 1. Plus, we need to differentiate 1. The derivative of a constant is 0. Derivative is measuring the rate of change. Constant is not changing. So how many changes has happened? 0. Divided by my x squared plus 1 all squared. And this will be equal to, if we clean up a little bit, this will be equal to 1 over 2 root x into bracket. I have my x squared plus 1 for this part here. Then we have minus 2x times the root x, all divided by x squared plus 1, all raised to the power 2. You can simplify a little bit, or you can leave your answer in this form. That depends on your level of algebra. Let's look at another example. Y is equal to, let's switch them around and see if we get the same answer. Let's put the x squared plus 1 at the top, and then the root of x at the denominator side. Once again, we cannot divide these two functions. Therefore, we need to treat it as two different functions. Next is to differentiate it, but there is an alternate way. And the alternate way is we can bring the denominator up and write this as x squared plus 1 times root of x raised to the power minus 1. All right, we can do it this way so that we can use the product rule. However, if we don't want to use the product rule and leave the function as it is, therefore, hence we have to use the quotient rule. And the quotient rule, our dy dx is equal to, keep the denominator constant, times differentiate the numerator. So here I have x squared plus 1. I'm going to put a prime at the top, minus the reverse. So if you get the first part wrong, the second part you're going to get it wrong. These follow a specific order. So keep the denominator constant, differentiate the numerator, minus the reverse. And the reverse is keep the numerator constant, x squared plus 1, and then differentiate the denominator. Root of x, I'm going to differentiate that all over the square of the denominator. The denominator is square root of x, so we are going to square that. They say square root of x. I have a prime on top of the x squared plus 1. That means that we need to differentiate x squared plus 1. So we differentiate the x squared, that will give us 2x. Plus, we differentiate 1, that will give us 0. Minus x squared plus 1. If we differentiate root of x, we've done this over and over, the answer is always 1 over 2 root x, all over square and the square roots. They get rid of each other. So from the denominator side, I'm going to have just x. Let's open some brackets and do some simplification. Here I'll have root of x times 2x minus 1 over 2 root of x times x squared plus 1 all over x. You can simplify this a little bit, or you can leave your answer as it is. If you simplify this a little bit, we'll have 2 root x, because everything is being divided by x. This x will cancel that x. Then the same x will have to cancel some x's over there. So this is minus, well, we cannot cancel. We'll have 1 over 2 x to the power 3 on 2 x squared plus 1. And that is our answer if we decide to simplify a little bit, or you can leave your answer once you get to this point here. Last one, and then we'll move on. Y is equal to 4x cubed plus 2x plus 1 divided by x to the power 7 plus 6. To differentiate this function, we can leave it as it is, leave it in the quotient form, or we can just change it into the product section and use the product property. But within that, you have to use chain rule. If not, I'm not sure a lot of you understand the chain rule yet. So let's leave it as it is and then use the quotient property. And using the quotient property, we need to follow specific order. And that specific order is to maintain the denominator as it is. Do not differentiate it. Do not multiply it by anything. So we maintain the denominator, x raised to the power 7 plus 6. And then we differentiate the numerator. So the numerator is x to the power 3, 4x to the power 3 plus 2x plus 1. I'm going to differentiate this, so I'll put a prime at the top. Minus the opposite. So I'll maintain the numerator, 4x cubed plus 2x plus 1, and differentiate the denominator, x to the power 7 plus 6. I'm going to differentiate it, so I'll put a prime at the top. All over square of the denominator, x to the power 7 plus 6, all squared. Let's differentiate and simplify. So this is x to the power 7 plus 6 times, we are differentiating what is inside this bracket here. So 1 by 1, we differentiate this here, and that will be multiply the 3 by the 4, that will be 12x. Subtract 1 from the 3, 12x squared. Plus, differentiate the 2x. The x here has 1 at the top. So we multiply the 1 by the 2, that will be 2x. Subtract 1 from the power. The power is 1. 1 minus 1 will give me 0. Plus, differentiate 1. The derivative of 1, which is a constant, is 0. So that is the derivative of the function in that bracket. Minus, we go to the right-hand side. We are maintaining the first term. So we have 4x cubed plus 2x plus 1 times, we have to differentiate this here. And to differentiate x to the power 7, that will be 7x to the power 6 plus the derivative of 6, that will give me 0, divided by x to the power 7 plus 6 all squared. And that is the derivative using the quotient rule. The rest is to clean up a little bit. So this is equal to x to the power 7 plus 6 into bracket. I'll have my 12x squared. I have plus 2. X raised to the power 0, that'll be 1. 1 times 2 is 2. 0 there, so I have just 12x squared plus 2. Minus my 4x cubed plus 2x plus 1 into brackets. I have 7x raised to the power 6 all over x to the power 7 plus 6 all raised to the power 2. You can decide to leave the answer in this form, or you can decide to simplify it depending on how strong your algebra is. All right, so that is for the quotient rule. Quotient rule, we use the quotient rule or the quotient property of derivative when the function is in the quotient form. And so to differentiate this, maintain the denominator times differentiate the numerator, minus differentiate the denominator, maintain the numerator, divided by the denominator squared. And that is the quotient property of derivative. It's a lot, but with constant practice, you will be fine. Any questions?
Yes, madam.
All right.
And please, can you go up? There is one example you gave about the quotient that's up there.
Yeah, this is the quotient. The quotient starts from
Yeah,
here.
the one that says x squared plus 1.
Mm-hmm.
So the other example you gave about this one, x squared
I
plus 1
reverse.
over square root.
Yeah, is this one?
Yes. And please,
Okay.
can we start from the power rule with the numerator?
What do you mean? Can we start with the power rule with the numerator?
So I'm thinking the x raised to the power 2.
Mm-hmm.
We use the
The
power rule
power,
on it. So
yes.
yeah,
Yes.
all right.
Yeah, we use the power rule because the x squared is in the power form. We use power rule throughout with the differentiation. After writing the function, using the quotient property, differentiating the function itself, we use the power rule property throughout because every single term within the function is in the power form. So there are two properties that we have used. We have used the quotient rule, and that is because the function y is in the quotient form. I have the top, let me pick up my pen. I have the top and I have the denominator. So we use the quotient rule. But differentiating the individual terms, we use the power rule because the individual terms are all in the power form. So it's a combination. Any other questions? All right, so if there are no questions, then let me ask my questions. Since I told you to watch up to the implicit. Given function, what is the difference between y is equal to f of x and y minus f of x? What is the difference between these two functions?
Madam, the second one is implicit
The second, why is it implicit?
because the y has not been made a constant. I mean, it has not been uh, like
Clearly been defined.
exactly.
Yes. All right, so since y in the second function, y has not been clearly been stated that y is equal to so, so, and so. There's no clear definition for y. Therefore, there's no explicit definition for y. And so the second function here is said to be in the implicit form. But for the first function, y has been explicitly been defined. Therefore, y is equal to f of x is said to be in the explicit form. And so to differentiate functions, we need to look at the way the functions have been expressed. If y has been clearly been stated that y is equal to this, there's an explicit definition for y, then such a function is said to be in its explicit form. Therefore, differentiating it, we just differentiate the left-hand side, that would be dy dx, indicating that we have differentiated variable y with respect to variable x. That is how come we write dy dx on the left-hand side. If y is equal to f of x, y is said to be in its explicit form. Therefore, to differentiate it, we just simply write dy dx is equal to the f of x dx. All right. So for the left-hand side, the y here means we are differentiated variable y. The x here means that we are differentiating everything with respect to x. So the numerator indicates the type of variable you are differentiating. The denominator tells you the variable with which you are differentiating with respect to. Meaning, if the variable in the function is t, then on the left-hand side, we'll write the y dt. All right, so if the function were to be y is equal to f of t, then our numerator will still be dy, because the variable that has been defined here is y. So we are differentiating variable y, but with respect to variable t. So the denominator side becomes the t. If we had y is equal to f of m, then to differentiate this, y has been clearly stated. So there is an explicit definition for y. Therefore, we use explicit differentiation, meaning differentiate the y. So we'll write the y over what variable are we differentiating with respect to. Since the variable that y has been expressed with is m, the denominator side becomes dm. Then you go on to the right-hand side and differentiate every single term. This is known as the explicit differentiation. When you have explicit definition for your function, to differentiate it, just write dy, meaning y has been defined. Y is the name of your function, over the x, meaning y contains x's. So the denominator side represents the variable with which you are differentiating with respect to. The numerator, the y, represent the change in the function itself. So the top represent the name of the function. The denominator represents the variables that the function has been expressed with. However, if the y has not been clearly stated, there's no clear definition for y, and we have y minus f of x, something like this. Y has no explicit definition. Therefore, this is known as implicit function. Maybe equal to a C here. This is known as an implicit function. To differentiate implicit function, we use the same techniques that we have used. The only variation here is after differentiating the y, we attach that we have differentiated variable y with respect to variable x. If we differentiate the f, we indicate that we have differentiated variable f with respect to x. And if we differentiate the c, we indicate that we have differentiated c with respect to x. All right, so Can you mute your mic, please? So if we have x, or let me bring the y first. If we have y squared minus x squared is equal to 9, since there's no clear definition for y, we have not clearly stated that y is equal to f of x. An expression on the right-hand side should be purely in terms of x. On the left-hand side should be just y, but that is not the case for this expression here. Y squared minus x squared is equal to 9. This is an implicit function. And to differentiate an implicit function, we use implicit differentiation. The difference here, the difference between implicit differentiation and explicit differentiation is, with explicit, we just write the y dx on the left-hand side, and then we just go ahead and differentiate the right-hand side. However, since there's no explicit definition for y, we leave the function as it is and then differentiate it. But after differentiating, indicate you have differentiated this with respect to that. So we go to the first term. The first term of our function is y squared. We differentiate the y squared. Y squared is in the power form. So to differentiate y squared, we need to use the power rule. So from the power rule, you multiply the 2 by the y, that will be 2y. Subtract 1 from the power. The power is 2. If I subtract 1 from 2, I'll be left with 1. But any number y raised to the power 1 is the same as y. So I have just 2y. Since we are differentiating this implicitly, we have to attach that we have differentiated variable y, but we are differentiating everything with respect to x. So we attach a dy dx. First, differentiate the y squared. That will give you 2y. Indicate that you have differentiated the variable y. So you write dy over dx. Why the dx? Because the variable with which I am differentiating with respect to is the x. If I was differentiating with respect to t, then at the denominator side, I'll write a t there. But since I'm differentiating with respect to x, at the denominator side, I'll write dx. Minus, we go to the second term, x squared. If we are to differentiate x squared is in the power form. So to differentiate this function, we need to use the power rule of differentiation. And that is to multiply the power by the x. That will give me 2x. Subtract 1 from the power. The power is 2. So 2 minus 1 will give me 1. But x raised to the power 1 is the same as x. So the derivative of x squared is 2x. This is implicit differentiation. So whatever you do there, you attach, I have differentiated. What type of variable did you differentiate? I differentiated variable x. With respect to what variable? I am differentiating everything here with respect to x. So here too, my denominator will be dx. This is equal to, we go to the right-hand side, 9. 9 is a constant. If you differentiate a constant, you're always going to get 0. It doesn't matter whether I attach dx dx or dy dx, it will always be equal to 0. Then next is to get simplified. We'll have 2y. Can you mute your mic? I have the x and then the x. They cancel each other. The x and the x will give me 1. So I have 2x times 1, that is. Irene, please can you mute your mic? The echo is some variable.
Oh. Hmm.
The feedback is very piercing, Mike, because I'm using some headphone.
Admin, mute everyone. Eh?
And even the co-host, they can mute.
Host, mute everyone.
All right, so we have minus 2x, the dx and the dx gives us 1. So 2x times 1, that is a 2x, and this is equal to 0. We are looking for dy dx, so we make dy dx the subject. And in the process of doing that, we can send the 2x to the other side. So we have 2y dy dx, this is equal to 2x. Next is to divide both sides by 2y. So I divide here by 2y. I'll divide here by 2y. The y, 2y and 2y gets rid of each other. So we have dy dx is equal to 2x over 2y. But 2x over 2y, 2 here, 1, 2 there, 1. So this is equal to x over the y. And so if you use implicit differentiation, this is the answer that we are going to get because the function was in the implicit form. Let's look at another example. We have x cubed minus y squared plus y minus 3x equal to x. To differentiate this function, well, we cannot write this in an explicit form, so we leave it as it is and treat it as an implicit function. Therefore, to differentiate it, we need to use the implicit differentiation. The slight variation with the implicit differentiation is attach a dy dx if you differentiate variable y. Attach dx dx if you differentiate variable x, because you are differentiating everything with respect to x. All right, so to differentiate this, we go to the first term, x cubed. If we differentiate the x cubed, that will give us 3x squared. And then we attach that we have differentiated variable x. And since we are differentiating everything with respect to x, my denominator becomes dx. Minus, we differentiate the y squared. To differentiate y squared, multiply the 2 by that, so I have 2y. And attach that we have differentiated variable y, and we are differentiating everything with respect to x. Plus, we differentiate the y. Y on its own is y to the power 1. So using the power rule, you multiply the 1 by the y, that will be 1y. Subtract 1 from the 1, that will be 0. Let's work on this a bit. Y raised to the power 0 will give us 1. So here will be 1 times 1, and the answer is 1. All right, so here I have 1 times, what kind of variable did we differentiate? A y. And with respect to what variable are we differentiating to? We are differentiating everything with respect to x. So here I have my dy dx. Minus, we differentiate the 3x. If we differentiate 3x, we have 3. The x becomes 1. Then indicate that we differentiated x with respect to x. And this is equal to, we go to the right-hand side and differentiate what we have there. What we have there is x. X on its own is x raised to the power 1. It's in the power form. Using the power rule, multiply the power by the x, so I have 1 times x. Subtract 1 from the power. 1 minus 1, that will give me 0. X raised to the power 0 is 1. 1 times 1 is 1. So here to I have 1 times, we differentiated variable x with respect to variable x. Now let's simplify and see where we can clean up, where we cannot. I have the x, that will give me 1. I have the x, that will give me 1. I have the x, that will give me 1. So if I drop all the dx, we have 3x squared minus 2y dy dx plus 1 times dy dx will give me dy dx. Minus 3, this is equal to 1. We are looking for dy dx, so we make dy dx the subject. To make it a subject, we want to make sure that it is standing alone on the left-hand side. Everything else goes to the right-hand side. So our first attempt is to maintain all the dy dx on the left. So maintaining that, we have the 2y dy dx, and I have my 1 dy dx. Or let me leave it as it is. We have to send this to the other side. So this is equal to, I have 1 there already. If I send this to this side, it becomes minus 3x squared. And I also have to send a minus 3. If minus 3 comes here, it becomes positive 3. 3 and 1 will give me 4. So I can clean this and get 4 minus 3x squared. We are looking for dy dx. So I have 1 here, 1 of them over here. Therefore, we can factorize dy dx out. So I have dy dx out. What I'm left with is minus 2y plus 1. And this is equal to 4 minus 3x squared. To get dy dx to stand alone, we have to divide here by minus 2y plus 1. Divide here by minus 2y plus 1. This and that will get rid of each other. So our dy dx is equal to 4 minus 3x squared divided by minus 2y plus 1. And that is our solution when we use the implicit differentiation, because we left our function as it is, treated it as an implicit function, and therefore we have to use the implicit differentiation. One more example, and then I'll take questions. Let me make this interesting a bit. Class. All right, so to differentiate this function, first of all, we need to understand the type of function that it is, and then we use the correct technique. The type of function this is it's an implicit function. And why is it an implicit function? Because there's no explicit definition for y. That is why it is an implicit function. To differentiate implicit function, we use implicit differentiation. Implicit differentiation takes the same technique or uses the same technique as the explicit differentiation. The only thing that is different here is after differentiating every single variable, attach that you've differentiated this variable with respect to that variable. So first, we need to define with respect to what variable are we differentiating. We are differentiating everything with respect to x. So at the back of your mind, you should note that since I'm going to attach a dy and a d something, all my denominators must be dx, because we have clearly stated that we are differentiating everything with respect to x. So the denominators must all be the dx. Next is to go to the function, look at the different forms or different parts that comes together, and then you use the correct technique. From the first part, we have x to the power 4, y to the power 4 multiplying. All right, so from the first part here, the x is not standing alone, the y is not standing alone, it's a product. Therefore, to differentiate this, we need to use the product rule. If the operator between them was a summation operator, then we'll differentiate the y to the power 4 plus differentiate the x to the power 4 plus differentiate the y to the power 4. But the operator between them is the product operator. And so we need to use the product rule of differentiation. All right, so with the product rule, it states that keep one of them constant, differentiate the other. So if I'm to keep x to the power 4 constant, then it means that I need to multiply this by differentiate the second function. Differentiating y to the power 4 will give me 4y to the power 3. I have differentiated a specific type of variable, and that is the y, with respect to x. So I attach a dy dx. We are still using the product property because for the product rule, keep one constant, differentiate the other, plus the reverse. So plus, since we kept x to the power 4 constant, this time we are keeping y to the power 4 constant. So y to the power 4, and then we differentiate the x to the power 4. The derivative of x to the power 4 will be 4x cubed. Attach your differentiated variable x with respect to variable x. And that completes the product rule for the first part. So this is the derivative of this side here. Now let's go to the second term. Plus, what is the derivative of 3x cubed? It is in the power form, so we multiply the power by the 3. 3 times 3 will be 9x. Subtract 1 from the power. 3 minus 1, that will be 2. Attach a dx. The top dx means that I've differentiated variable x. The bottom dx means that I am differentiating everything with respect to x. Then we go to the third function and differentiate that. So we have minus. If we differentiate 4y raised to the power 6, it's in the power form. So you multiply the 6 by the 4, that will be 24y. Subtract 1 from the 6, that will give me 5. Attach a dy dx. The dy means I have differentiated variable y. The dx means I have differentiating everything with respect to x. This is equal to, we go to the right hand side, differentiate 3. 3 is a constant. Doesn't matter with which variable you're differentiating with respect to, the answer is always equal to 0. All right, so we go in there and then we simplify it a little bit. From the first term here, x to the power 4, 4y to the power 3, that will be 4 x to the power 4, y to the power 3, dy dx. Then we have plus 4 y to the power 4, x to the power 3, dx dx. Plus this expression here, 9x squared dx dx. Then we go to the third term here, so the fourth term, minus 24y5 dy dx. Everything is equal to 0. Let's simplify a little bit and drop the dx dx. How many dx dx can we drop? I have 1 dx dx here, 1 dx dx there. They give me 1. 1 dx dx, 1 dx dx, they give me 1. So we can drop those ones. And so we have 4x to the power 4, y to the power 3, dy dx plus 4y to the power 4 x to the power 3 plus 9x squared minus 24y to the power 5 dy dx. This is equal to 0. We are looking for dy dx, so we make it the subject, thereby grouping like terms. So we have 4x to the power 4 y cubed dy dx. I'll join it with the other dy dx. Minus 24y5 dy dx. Then I'll send everything else to the right-hand side. This is equal to, if I send this to the other side, since it's positive now, if I send it there, it becomes negative 4y4 x to the power 3. Then I'll send this to the other side. It's also positive. So if I send it there, it becomes minus 9x squared. Next step is to factorize the dy dx because we are looking for the dy dx. So we have dy dx out, and we are left with 4x4 y cubed minus 24y to the power 5. This is equal to minus 4y 4x cubed minus 9x squared. How do I make the y dx a subject? Divide here by 4x cubed, 4x to the power 4y cubed minus 24y5. Divide here by the same thing. 4x 4 y cubed minus 24 y to the power 5. This and that will give us 1. So my dy dx is equal to minus 4 y to the power 4 x cubed minus 9x squared divided by 4x to the power 4 y cubed minus 24 y to the power 5. And that is our answer if we use implicit differentiation. Right. Any questions? I'm sure you have a million and one. Any questions?
Madam.
Yes.
Madam, please, since the xds cancel out, is it necessary? Can we ignore it?
Yeah, you can.
All right.
You can ignore it. Because essentially, like you mentioned, you brilliantly stated, we are going to cancel them out. Do we necessarily need to write them down? No, you don't. But for the first time, yes, we do. So that if somebody asks you, why is it that some parts you have dy dx, in some parts you didn't attach, then you can show them that it's because I got a dx yet. You can just choose to ignore that part. Any other questions? There be no question. So if there are no questions, we'll pause here and then continue next week. Please, there will be questions on the LMS on these coming up very soon. Our next topic will be the application of differentiation. I've sent the videos. Please watch the videos. I will resend it for the sake of those that joined late. I will resend the videos so that you can watch the video. It's applications of derivative, finding the equation of a tangent line, finding the critical or turning or stationary point, and the nature of the stationary point. I will resend the video so that you watch them. So next time when we're looking at it, it will not look like an alien to you. I'll also send the board shortly on our Telegram page as well. All right. Okay, so I'll leave you to read over your notes on your next topic or next subjects that you're going to do.
Yakubu, manage.
Madam,
Okay,
God bless you. Bye bye.
where is the
Bye-bye.
apple? Madam, is she gone?
Madam Oko.
Madam Ko.
Madam, you forget Apple. Apple, you say you will give Apple.
It's not Apple. Like,
it's being recorded. The thing is being recorded.
Please listen. It's not Apple. You see, just like the the topics that we, just like the way
Yeah,
Yeah, yeah, yeah. We
exam
know,
algebra,
review.
you
yeah,
see,
we
just
know
like the,
that.
the way the algebra lecturer did
Please, we
for us,
can
like
discuss
yes,
this in the main group. We can discuss this in the main group. Thank you.
Yakubu,
okay.
No, but I don't
manage.
think what Hakim is saying is far off. It's Apo
I'm
Islam
not. I'm
for
not.
review
No,
of
I'm not
it.
saying what
Normal.
he's saying is wrong or something. That's not what I'm
Okay,
saying.
okay,
I'm
okay.
just
Please
saying.
let's discuss backdoor, please. Thank you.
Yeah.
Thank you very much.